Okay, let's jump right into the financial future, because we are no longer talking about machine learning and deep learning as these, theoretical concepts.
Not at all.
They've become the essential day-to-day infrastructure of global finance. It's almost like the new operating system for modeling risk and predicting markets.
It's the sheer computational power married to the explosion of high-frequency and multidimensional data that really forced this shift.
Right.
Your traditional decades-old econometric tools simply couldn't handle the data volume
Mm.
or the speed.
So our mission today is to cut through the noise and give you the most concise and cutting-edge view of this fintech revolution. We've synthesized a systematic review.
Which is an analysis of 22 of the freshest peer-reviewed studies, all published between 2024 and 2026.
Yeah, so this is less about history and much more about what's working right now to reshape forecasting, asset pricing, and even banking supervision.
And the fundamental premise these models are built on is, well, it's complexity. ML and DL models are prized precisely because they excel at capturing these complex nonlinear relationships in huge data sets.
The kind of chaotic patterns that older models would just miss.
Exactly. The kind of subtle patterns that traditional statistical models, which were designed for much cleaner data, they inevitably miss. They're finding alpha in the statistical weeds, so to speak.
That sets the stage perfectly. So let's start with the AI toolkit itself. When researchers or, practitioners decide they need an AI solution in finance, what specific models are they reaching for and why?
It's a very practical choice. It's really driven by the type of data they're looking at.
Okay.
If you have structured, static data, think of a snapshot of a person's financial history for a loan application or general company characteristics for asset pricing. You still see this tremendous reliance on the traditional workhorses.
You mean things like random forest and XGBoost?
Exactly those, random forest and XGBoost.
Those are powerful. They're proven models. But what makes them stick around in a world that's chasing deep neural networks?
Two things, really. Interpretability and speed. Compared to the massive deep networks, XGBoost and Random Forest are robust, they're incredibly fast to train, and they offer much better visibility into how a decision was reached. And that's critical for a task like credit risk, where you have regulatory compliance that just demands a degree of explainability.
That makes perfect sense. So they offer this balance of high performance and relative transparency. But financial markets are fundamentally dynamic, right? They're sequential and chaotic. You need to remember the order of events, the temporal dependencies.
Exactly. And when the data is sequential, especially high-frequency time series like, minute-by-minute trading data or volatility patterns, that's when the deep learning specialists really dominate.
Okay, so now we're talking about LSTMs and RNNs.
We are. We see long short-term memory, LSTMs, and recurrent neural networks, RNNs, leading the charge because they are specifically built with internal memory to handle those sequences. They actually learn patterns in time.
So you have these robust interpretable models for static tasks on one hand, and then specialized memory networks for time series on the other. But the review highlighted a third approach that is, statistically speaking, the current leader in performance.
That's the hybrid trend, and this is where researchers are finding genuine breakthroughs.
So instead of just picking one.
Right. Instead of relying on a single architecture, they're building ensemble and hybrid models that combine the strengths of different components. You're often mixing statistical rigor with deep learning flexibility.
Can you give us a concrete example of that hybrid power?
Certainly. One really prominent finding, it was documented in a study from 2025, showed that hybrid ML models, specifically, one combining an LSTM component for the nonlinear time patterns and an ARIMA component for the linear trend.
So old and new together.
Old and new together. And it dramatically outperformed any single standalone model for predicting financial volatility. You use the statistical part to filter the basic noise and the deep learning part to find the complex, hidden relationships. It's the ultimate best of both worlds approach, and it is clearly the dominant path forward.
So it sounds like the era of choosing Model A or Model B is over. Now it's about figuring out the optimal way to marry them.
That's it.
Okay. So we've armed ourselves with the right toolkit. Now, let's see where researchers are pointing these tools. The review found that AI applications are diversifying well beyond just, predicting stock prices.
But 22 studies were classified pretty neatly across 4 distinct and expanding domains.
All right, let's start with the classic, the legacy domain. Stock market forecasting and asset pricing. This is the oldest application, still the biggest slice, with 8 of the studies focused here. What new insight are they delivering that the traditional capital asset pricing model, the CAPM, missed?
The key is adaptive learning. Traditional models are static. They really struggle to integrate dozens, let alone hundreds, of potential market factors at the same time.
Right.
ML-based factor models, on the other hand, can process these vast arrays of risk premia, macro variables, and adapt their weighting almost instantaneously. The review found these new factor models significantly improve asset pricing performance because they just capture the nuances of risk better. They provide a far more dynamic picture of fair value.
That's a huge quantitative improvement. So moving to the second largest area, credit risk and loan default prediction 6 studies here. This is a highly regulated space. What's the primary benefit ML is bringing?
It comes down to accuracy in prediction. And that translates directly to enhanced banking supervision and better portfolio management.
For example.
For example, the review cited studies showing improved credit scoring accuracy in specific localized banking systems, like in Turkish banks. It shows the models can be optimized for local regulatory and economic environments.
So it's not one size fits all.
Not at all. And they're not just being used to prevent defaults, but to predict post-default recovery rates, how much a bank can actually get back from a defaulted loan. That's crucial for managing your overall credit portfolio risk.
It sounds like this domain is really the proving ground for that accuracy versus compliance conflict we're going to talk about. If you get the prediction wrong here, it affects someone's actual life or the stability of a whole institution.
Precisely. The stakes are absolutely highest here.
Okay, our third domain, with 5 studies, dives into the chaos of cryptocurrency and volatility forecasting. Why is deep learning particularly so indispensable in this market?
Because the crypto market is just defined by high velocity and extreme volatility.
I'll see.
The data is high frequency, it's fragmented across exchanges, and it often moves based on social sentiment, not traditional economic fundamentals. Standard econometric benchmarks, which assume some degree of, normality, they just fall apart.
So they're just not built for that kind of chaos.
Not at all. Deep learning models, especially LSTMs and GRUs, are better suited to handle the sheer speed and the non-Gaussian nature of the data. They provide demonstrably superior short-term forecasts compared to anything we used 5 years ago.
So if you're trading crypto, you are almost forced into these deep learning architectures just to keep pace. Finally, the fourth domain, which I found fascinating, showcases the true diversification of AI's reach: macroeconomic and policy forecasting. Only 3 studies, but this is far outside the standard stock market box. What stood out here?
The surprise was seeing ML algorithms like gradient boosting being used to predict policy outcomes. They're being used to forecast how public funding will be allocated across different policy areas.
So this isn't about maximizing profit.
No, it's about optimizing public service delivery. They're also improving actuarial predictions by processing these vast, high-dimensional economic data sets that traditional regressions just couldn't handle. It shows that AI's predictive power is rapidly integrating into government, not just trading floors.
Okay, that solidifies the big finding that ML and DL consistently deliver higher predictive accuracy and robustness across all 4 fields. But now we hit the critical pivot point where the data starts to, contradict the real-world application. Let's talk about performance metrics.
This is perhaps the most crucial insight for anyone listening who wants to apply these models. There's a distinct disconnect between what researchers optimize for and what investors actually need.
How so?
Well, overwhelmingly, the study's 17 out of the 22 papers, they focus on statistical goodness of fit metrics. They obsess over root mean squared error, RMSE, and mean absolute error, MAE, for forecasting.
Right, or accuracy in F1 school for classification.
Exactly. These metrics tell you how well the model fits the training data.
So the model is statistically perfect. It's like having a theoretically perfect engine on a test bench. But you're arguing that statistical perfection doesn't necessarily translate into financial success.
Precisely. Only a tiny fraction of the studies, just 4 papers, bothered to validate their models using actual financial or economic performance indicators.
Like Sharpe ratio or portfolio return.
Things like the Sharpe ratio, portfolio return, or reduced maximum drawdown. This is a massive gap. If a model lowers your RMSE by 10% but fails to improve your Sharpe ratio, your return per unit of risk, is it actually useful to an investor?
Well, the answer for a professional portfolio manager is clearly no. You can have a statistically beautiful model that generates great predictions but results in terrible decisions if its errors happen at the worst possible time.
You're optimizing for the wrong target.
We need to see more models validated not just on how well they fit the past, but on how much money they make or how much risk they save in a simulated trading environment.
And this failure to connect the technical rigor with economic validation remains a chief barrier to mass adoption in investment management.
Okay, let's move to the other colossal obstacle that stands in the way of AI replacing all traditional models. The black box, the interpretability hurdle.
This is the legal and ethical pinch point. For deep learning models, despite their superior accuracy, their opacity remains the primary limiting factor, especially in highly regulated domains like banking and insurance.
Regulators and consumers demand an explanation.
They do. If a black box model tells a bank to deny a small business loan, the bank needs a defensible, understandable reason, not just a high confidence score from some algorithm.
So how do we get around this without sacrificing the accuracy that these deep networks provide? Is there a solution?
The field is rapidly adopting what's called explainable AI, or XAI. We're seeing a major trend toward incorporating model-agnostic XAI techniques. These are methods that sit outside the model, analyzing its outputs to sort of reverse engineer why it made a specific prediction.
So it's like we're using one layer of AI to decode another layer of AI.
In essence, yes. The prime example cited in the literature is SHAP, that stands for Shapley Additive Explanations. SHAP values allow researchers to quantify the contribution of each input feature, say income or debt level, to the final prediction made by the opaque model.
And that gives you the transparency you need.
It provides the required transparency without forcing people back to the less accurate older models. We see this used heavily in credit risk research, specifically because of those compliance demands.
This balance accuracy plus accountability, it really feels like that defines the future of development in finance. So let's synthesize the big picture takeaways now. We've established the dominance of hybrid models, the expansion into government and crypto, and the positive trend toward reproducibility using open source tools like Python.
Those are the accomplishments, definitely.
Mm-hmm.
But to understand where the field is going, we have to discuss the three significant gaps that remain unfilled. These point to the necessary future evolution of the field.
Okay, you call the first one the economic validation gap, which we just touched on with the whole RMSE versus Sharper ratio issue.
It's the persistence of that gap. Despite 2 years of intense publishing, there's still very limited systematic assessment of how improved statistical accuracy translates into real financial performance or measurably reduced risk exposure. The academic world is still a little bit detached from the trading desk.
And that gap needs to close.
It absolutely needs to close if these models are to be taken seriously by major institutions.
Okay, the second gap deals with the data itself, the generalization gap. Isn't all financial data inherently a bit local? How can we expect a model trained on, say, the Saudi stock exchange to generalize perfectly to the Australian equity market?
That is the heart of the challenge. Many of these studies rely on proprietary or geographically limited local data sets. And while those models might perform excellently within their specific sandbox, it severely limits their cross-country comparability.
And their utility for global investors.
And crucially, their utility for global investors or international banking supervisors. For a model to be truly transformative, it needs to demonstrate its utility across diverse regulatory and economic regimes. Generalization isn't about perfection. It's about establishing robust applicability.
So if the model is so specialized that it only works for Turkish banks or the Saudi market, it's not a global technology yet. It's a localized optimization, which restricts its investment appeal.
Exactly. And that leads to the final gap, the integration gap. This speaks to the current state of how models are tested.
Mino.
Most ML models are currently tested in isolation, almost like an independent predictive module. They are rarely integrated into broader, dynamic financial systems or multi-agent simulations that truly capture the interactions of a real market.
So it's like testing a new jet engine in a perfect lab vacuum instead of putting it on a plane flying through real turbulence.
That's a perfect analogy. We're still evaluating predictive performance independently, rather than embedding the machine learning within actual competitive, dynamic decision-making structures where other agents, both human and algorithmic, are reacting to its presence.
Because the performance of an algorithm depends not just on its own power, but on how everyone else responds to its outputs. That's a fascinating point. This lack of dynamic system testing must be a major limitation.
It absolutely is. True validation requires seeing how the model behaves when it's one player in a high-stakes game.
That provides a clear and powerful trajectory for the next few years of AI in finance. The next phase isn't just about finding the next slightly better neural network architecture, is it? It's about achieving that critical balance between technical rigor, economic validation, and regulatory interpretation.
It's the shift from simply calculating better numbers to making better and more accountable decisions.
Which leaves us with this final provocative thought for you to consider. Given the transformative power of these ML and DL models and the ongoing persistent challenge of the black box nature they present, how far away are we from a regulatory environment where policymakers and regulators demand interpretability over sheer statistical accuracy as the primary measure of AI success in high-stakes financial systems? If those two criteria conflict, which one will ultimately win the compliance war? That tension between performance and accountability, that's the true next frontier we are all facing right now.